Welcome to Algebra 2. Today we're going to be discussing logarithm and logarithm functions. So far in this unit we've only talked about exponentials. So today we're going to learn that the logarithm is the inverse of an exponential function. And inverse functions are when you switch the x and the y values. So if we have y equals b to the x, our exponential function, x equals b to the y would be the inverse. We just simply swapped the x and the y values. And another way to write x equals b to the y is y equals log base b of x. And log stands for our logarithm function. Okay. Notice b, our base value, is also b, our base value on the log as well. So what we're going to do is we're going to just practice writing it in either form. So first, we're given these in logarithm form. We want to write them in exponential form. So here I have log base 3 of 9 is equal to 2. So I'm going to look, it's currently in the logarithm form. I want to put it in the exponential form. The base number is going to be the same, so here's my base number. So I know my base number is 3. It is raised to the second power, and that should equal 9. So 9 equals 3 squared. Okay. Next up, here we have 1/100th is equal to, this should be 10 to the negative 2 power. So there we're simply rewriting these in exponential form. Now we're going to do the reverse. So now I have it in exponential form and we want to rewrite in logarithm. So 5 to the third is equal to 125. So this tells us then we had to have log base 5, so our base number stays the same, of 125 is equal to 3. And then you can just mentally check that you took your base number to the third power, which is what we started off with. Second one, 27 to the 1/3 is equal to 3. So here, log base, our base number is 27, of 3 should equal 1/3. And once again, you can mentally check that you're taking your base number raised to that value on the other side of the equal. So now we're going to take this and we are going to evaluate each expression. So we need to figure out what would this equal here. Okay, what would this equal? So if we have log base 3 at 243, what's that going to equal? So we think 3 to the what power gives us 243. Then we go through and we think of our threes. So we know 3 to the third is 27, 3 to the fourth is 81, 3 to the fifth is 243. So there we just found it. So this is equal to 5 because 3 to the fifth is equal to 243. Alright, next example. Log base 9 of 9 squared. Well, what does this equal? So 9 to the what power gives you 9 squared? Well, this one seems pretty obvious. Our what power would have to be the 2. So 9 to the second power. So this would equal 2. Next one. 7 to the log base 7 of x squared minus 1. This one might be a little bit more difficult to think of. So since this has a log and an exponent, we're going to rewrite this exponent as a logarithm. Okay, so this is log base 7 of what should equal log base 7 of x squared minus 1. So we just took this and we rewrote it in a logarithm the same way how we rewrote those in a logarithm. So, well, that what we can clearly see now should be x squared minus 1. So this is equal to x squared minus 1. I want you to notice something here, that this base number and this base number are the same. That's going to come to be key here. Base number, the same. We get x squared minus 1 left. Even in the previous example, base number are the same, and we just got 2. That's going to be a pattern that's going to continue on. We'll do one more of these. Log base 2 of 64. So we want to think 2 to the what power gives you 64. Well, let's see here. Well, we know 2 to the third is 8. 2 to the fourth is 16. 2 to the 5th is 32. So 2 to the 6th is 64. So this has to equal 6 because 2 to the 6th power gives you 64. Alright, and lastly with these logarithms is we are also going to graph them. So graphing these logarithms, there's a few things that we need to know. One thing that we always need to know is we need to pay attention to what our base number is here. Log base 5 of 5, this equals 1. This equals 1 because 5 to the first power is 5. This is always going to be our first thing that we know, is whatever our base number is, we know when we take the x value of that same number, it equals 1. This tells us the point 5, 1. Because our x was 5 and it equaled 1. That would have been like our y value. Alright, so that's the very first point that we know, is whatever base number that is. So if we have a base of 5, like we had a base of 5 here, that tells us we have the point 5, 1. So we're going to plot that point 5, 1. The second point that we always know is going to be log base 5 of 1. This is always going to be 0. Because here when we take 5 to the 0 power, it's 1. Anything to the 0 power is always 1. So this is going to be another point that you always know, is that 1, 0. It doesn't matter what your base number is, that's a point that's on every single graph regardless. So 1, 0. Okay? And then the one other point that we can figure out would be log base 5 of negative 1. So 5 to the negative 1 is 1/5. So log base 5 of 1/5 should equal negative 1. So that gives us the point 1/5 negative 1. So we're going to plot the point 1/5 negative 1. Now notice that this isn't really creating an XY chart. Instead, it's thinking about what these equaled, and those are like the exponents, and those end up being the y values over here. And these values over here ended up being the x values. So you have to really think about what they equal. These two are set. The base number, whatever the base number is, 5, 1 and 1, 0, those two will always be on there. But then you're going to have to figure out whatever fraction it is for that. And so we can connect these points. And there's our logarithm. Now, for logarithms, they do not cross the y-axis. Okay, so if we were to do the domain and range for this, here we would say the domain for our x values is x has to be greater than 0 here, because notice we are not crossing that y. Our x is only over there, our greater than 0 values. And the range here, although it may not seem like it, our range is all real numbers. This will continue increasing steadily. Alright, so this will eventually get larger and larger and larger. There's just a couple other things I want to tell you about logarithm functions. And that is what the parent function looks like. So the parent function for a logarithm function is f of x is equal to a times log base b of x minus h plus k. Where once again h is our horizontal translation, k is our vertical translation, and our a, if the absolute value of a is greater than 1, it is stretched vertically. If our absolute value of a is in between 0 and 1, it is compressed vertically. And if our a is less than 0, so if it's negative, this ends up being reflected across the x-axis. Notice that these are all the standard things that were also the case for exponential graphs. And what our H, K, and A represent here, these have also been held true for all the different graphs that we've talked about parent functions for. So that might help you graph some of these logarithms, but I really think the easiest way to graph these logarithms is to try to think of these 3 points. Alright, so that is graphing logarithms and logarithm functions.